So in the last video lecture, I introduced different types of hypothetical syllogisms. Now, of course, hypothetical syllogisms are ones that are probably pretty familiar to a lot of you. We use this form of reasoning very, very widely. What a hypothetical syllogism is just any kind of two premise argument with a conclusion that has a hypothetical proposition in it. As I said last class, there are two broad kinds. On the one hand, there is what we call a pure hypothetical syllogism, and on the other hand, there's what we call a mixed hypothetical syllogism. As you can see, and as I mentioned last class, the difference between the two is that in a pure hypothetical syllogism, every proposition and the conclusion is a hypothetical proposition. Whereas with a mixed hypothetical syllogism, typically you could have maybe two premises, I don't know, that are hypothetical, but you're going to have a premise that's non-hypothetical, and your conclusion is going to end up being non-hypothetical as well. Now, I don't know that I gave you guys a lot of examples last class, but I do want to just share with you a couple so that you can see the arguments here, because sometimes when you just see things written in symbolic form like this, it's a little abstract. So let's look at an example of a pure hypothetical syllogism. So here's an instance. If you take logic, then you will learn how to reason better. If you learn how to reason better, then you will be a cut above the competition. Therefore, if you take logic, you will be a cut above the competition. So notice in this one how basically what we do is we have multiple antecedents here, but we have this antecedent, you take logic, then it leads to this consequent, and then we take that consequent right here. If you know how to reason better, then you will be a cut above the competition. And then we end up down here with this conclusion, which is basically just, if you take logic, you will be a cut above the competition. So in this, 1 leads to 2, 2 leads to 3, so to speak. Or let me rephrase that. That wasn't quite worded correctly. But the idea is that the antecedent of 1 leads to this consequent, and then this consequent now becomes an antecedent in this proposition, which then leads to this consequent. And so basically, it's like A leads to B and B leads to C, so therefore A leads to C. That's the way that we're thinking here. But all of this in a pure hypothetical is, I'm not definitively concluding anything. I'm just saying if, right? And the conclusion is itself hypothetical. Mixed hypothetical syllogisms, these are very familiar, and I've given you guys a lot this semester already. But here's an oldie but a goodie. One that you guys have seen a number of times, but if you earn an A, you will pass this class. You will earn an A, therefore you will pass this class. And this is an example of I've used this a number of times in here, I believe, but a very clear mixed hypothetical syllogism. Notice here that the conclusion is itself not hypothetical. Now what we're going to do in this video lecture is I'm going to spend some time talking about different types of mixed hypothetical syllogisms. These are going to be the ones that we focus on. And we're going to look at different types and different patterns that are valid and different patterns that aren't valid. Now, here's the example I just presented to you, and this is one type of mixed hypothetical syllogism. And this is actually, believe it or not, it has a fancy Latin name. This form right here that you just saw, it's called modus ponens. And there's a certain form of this argument, and I think you guys are probably familiar with this form already, but and I'll come back to it. Well, I'll just go ahead and share it with you right now. But the form of this argument, you'll notice it's if, and we can say you earn an A, and we could put a P here for that, and then it should have it then there, but that's okay. Then you will pass the class, a Q here. And then we see P occur again. You will earn an A or you earn an A. It's just a difference in tense there, but that doesn't make a difference in the proposition, I don't believe. And then Q right here for this, and you see that pattern repeated. And so this has the form if P then Q, P therefore Q. And like I said, this is called modus ponens. Now, I remember when I first heard this, I was like, what in the hell does that mean? It's just Latin. And if memory serves, and I could be wrong about this, I guess I should have looked up, but I think it means the method of affirming. You might have heard the expression modus operandi. It just means kind of like your standard method of doing things. It's like, oh, this is, you guys might have heard it in like a crime drama. It's like, oh, this is the killer's MO. MO stands for modus operandi. Modus operandi just means kind of method of operation, right? Way of doing something. Modus means method. So this is right here, modus ponens, method of affirming. It's Latin. Because look at what you're doing right here. You're affirming. You're saying the antecedent right here is true. So it's the method of affirming. So modus ponens is just if P then Q, P therefore Q. And any argument, and I've said this before, any argument that has this form is a valid syllogism, a valid hypothetical syllogism. What makes it valid is not that the premises are true. What makes it valid is just that if 1 and 2 are true, then the conclusion must also be true. Well, there's another valid type of mixed hypothetical syllogism, and this one is a lot of time less intuitive to students, so I'm going to spend a little bit of time on this one. But it begins the exact same way. If you earn an A, then you will pass this class. You will not pass this class, therefore you will not earn an A. Now look at this one. Does this seem right to you? Take a second and think about it. If you earn an A, you will pass this class. Well, that seems true. And if I said you will not pass this class, well, if you're not passing this class, that means you are not going to earn an A. And some of you might be thinking, well, you could have had an A but then failed on attendance. But even if that's true, you're still not getting an A. So even if you got a 100 on everything but you fail on attendance, right? It's still the case that you are not earning an A in that class, or at least I should say it's not going on your report card. So this is an example of a valid form of mixed hypothetical syllogism. But what's the pattern here? Look at this. Earn an A. Let's just say we take earn an A to be P, and you will pass the class, and let's just say we use a Q for that. And now we come down here. You will not pass the class. Well, you will pass the class. Well, Q is you will, but notice it's saying will not. So this is going to be not Q right here. You will not earn an A. You earn an A. So this is going to be not P. And so the form of this argument right here is if P, then Q, not Q, therefore not P. And this has a fancy name too, and it's called modus tollens. And again, this is Latin, and I should have looked this up, so I'm going to get some emails telling me I'm wrong, but I think this means the method of denying. I think that's because, and that's what you're doing, because if you look right here, you're denying the antecedent. You're saying the antecedent, you're saying if P is true, then Q is true. I'm sorry, you're denying the consequent. Saying, and you're denying the consequent, and by denying the consequent, you're then denying the antecedent. But look at what you're doing here. You're starting with this proposition, which is the exact same as the one over here. But then you're denying the antecedent, and so denying the consequent is true. And this is actually a way of reasoning that we use quite regularly, where you'll say, well, look, if what you're saying is true, that leads to this other thing, but that other thing is false. So what you're saying must itself be false. I gave you guys, I think, an example like this a long time ago, but sometimes you'll hear an argument made like, or maybe someone says, well, let's talk about a hot topic. It's always a hot topic, abortion. Someone might say, well, I think abortion is always wrong. And you might say, well, look, if abortion is always wrong, then a woman cannot have one to save her life. But a woman can have one to save her life, therefore abortion is not always wrong. Notice what you did there is you denied the consequent in order to show that the antecedent was false. And that is a form of modus tollens. Just as a side note to that, there was actually, I don't know if you guys have ever seen Big Bang Theory or watch it, but in one episode, Sheldon, who's supposed to be the really nerdy guy, he talked about Leonard, how Leonard was using the fallacy known as reductio ad absurdum, which this is actually, modus tollens is, I don't know if you've ever heard it, I guess I should have had a slide on this, but it's a form of reasoning called reductio ad absurdum. And again, it's a Latin expression. Reductio ad absurdum just means reduction to the absurd, which is where you take what someone is saying and you say, well, look, if what you're saying is true, that leads to this absurd consequence. That absurd consequence is false. Therefore, what you're saying is false. The funny thing about that was, and I should have had a video or something on this, you can look it up. Look up Big Bang Theory, reductio ad absurdum. It's totally not a fallacy at all, which is funny because that show's typically really good about all the nerdy stuff. but it's not a fallacy. This is a valid form of reasoning. And this form of reasoning is always valid, because if a form of reasoning is valid, it always is. So this is modus tollens. And just to kind of share with you guys so you can see it without my poor drawings, you can see that the two forms right beside each other. Here they are. We have modus ponens on this side, which is just if P then Q, P therefore Q. Like I said, look what you're doing, you're affirming. You're right here, like I said, it's a method of affirming. You're saying this is true, therefore this is true. This is the method of denying, because you're saying the first is false, so the consequent is false, therefore the antecedent is false. And both of these are valid forms of reasoning. Now, a lot of times I feel like students have trouble understanding modus tollens. It's one that's a little less intuitive, or they might not quite get why it works. I don't know, I think the example I just gave you is pretty straightforward. If you go back to that one, if you earn an A, you will pass this class. I mean, if you're not passing this class, you are not earning an A. I mean, to me, that's just very straightforward how that works. But, I mean, we could put a lot of other things in place of the P and Q, and it'll always work as a valid argument. That doesn't mean it's a sound argument. It doesn't mean the premises are true, but let's think about it again with some other examples. Like, if you explode an atomic bomb on my head, I will die. Well, that seems true. If an atomic bomb explodes on my head, I will die. I'm not dead. Well, if I'm not dead, what does that mean? It means no bomb has blown up on my head. Now, I want to share with you guys one other thing, and this might help clarify modus tollens a little bit, but even if it doesn't, it serves another important point I want to share with you guys. And I want you to just look at this proposition, this argument right here, modus tollens. If P, then Q, not Q, therefore not P. And you may recall I've said before that when you have a hypothetical proposition, its contrapositive is logically equivalent. Well, what would be the contrapositive of if P then Q? Now, how do we find contrapositive? We switch the antecedent and consequent, and we negate both. So the contrapositive is going to be this: if not Q, then not P. Now, let's suppose once we have this right here, we have that contrapositive because they're logically equivalent. Well, then we can just reason, by affirming. And we could say, not Q, therefore not P. And notice right here, what we're doing is this is actually no longer in modus tollens. This is actually a form of modus ponens. Why do I say that? Well, look at what the antecedent is. The antecedent now is not Q. And the antecedent here is not P. Whereas over here, the antecedent is just P, and the antecedent is just Q. So in this argument on this side, we're actually denying the consequent, and we're denying right here the antecedent. But we're saying if not Q, then not P. Well, not Q is true, so we're affirming it. And we're saying, and the antecedent, not P, is true, so we're affirming it. And this might help, I don't know, maybe make modus tollens make a little bit of sense for some people who it didn't make sense for. Maybe it makes things more muddy than it previously did. But one lesson I want to share with you guys is that you can always rewrite modus tollens as a modus ponens and vice versa. You can always do that just by beginning and taking the contrapositive of the hypothetical proposition. If you do that, then you can just, if you don't like reasoning, as I have over here on the left-hand side, just say, well, let me take the contrapositive. This might be a more convoluted step than a lot of people want to take, but you could take the contrapositive of it and then just affirm everything from there on out. And again, when I say affirm everything, what I mean when you affirm stuff is you have to affirm the entire antecedent, which would in this case would be not Q, and you have to affirm the entire consequent in this case, which would be not P. That is going to be your antecedent. That is going to be your consequent. So, if you don't get what I'm saying on this slide right here, this is not an important thing. I shared this with you because some people find it helpful. Some people, it confuses the hell out of them. But then other people find it cool to know, and I think it is important to know, that you can transpose modus tollens into modus ponens and vice versa. Those two things, and all you have to do, like I said, is take the contrapositive of the hypothetical proposition. So If you don't get that, it's not going to be vital moving forward, but it is something that I think is interesting to know. All right, so I also want to talk about certain fallacies of hypothetical syllogisms, and there are two important ones we're going to focus on. And here's one that I gave you guys a long time ago, and you were able to identify. But look at this. If you get an A, you will pass this class. You are passing this class, therefore you will earn an A. And let's see if we can figure out what's the logical form of this. You get an A, right? And we're going to let that be P. You pass the class, and we're going to let that be Q. And then say you are passing, we'll put a Q here, you will earn an A. Look, you will earn an A, that's the same as you get an A. So the form of this is if P, then Q, Q, therefore P. But you should hopefully be able to see the fallacy here in this way of reasoning. This is not a sound way of reasoning at all. And you might remember a method of counterexamples. I mean, this is pretty easy to come up with a counterexample. You could say, well, look, it's definitely true that if you get an A, you will pass the class. And you could be passing the class by earning a B, so that would be true. But then it would be false that you will get an A. So by thinking of that, we thought of a way in which we could have true premises and a false conclusion. The hypothetical is obviously true. We can imagine a scenario in which this is true, you're getting a B, and then it's just no longer the case that the conclusion is true. It would be false. This is an invalid hypothetical syllogism. And like I said, it has the following form, if P then Q. And this has a name. This is a kind of common way that people misreason, we might say. And this is called the fallacy of affirming the consequent. And you can see why it's called the fallacy of affirming the consequent, because what are you doing? You're saying the consequent is true. And by saying the consequent is true, you're reasoning in a fallacious way. Now, if you affirm the antecedent, that is actually affirming the antecedent, which this makes sense, that's okay. That's actually modus ponens. But affirming the consequent, you don't say, if A then B, B is true, therefore A is true. If you shoot me in the face, then I will die. I'm dead, therefore you shot me in the face. That gets the logical order of things incorrect. So this is a fallacy, and it's actually, unfortunately, a common fallacy that people make, but it's one that you are going to be expected to know the name of, a fallacy of affirming the consequent. Here's another one. If you get an A, you will pass this class. You are not getting an A, therefore you will not pass this class. And let's see if we can figure out what the form of this argument is. Hopefully you can see that this is a fallacious way of reasoning. If you get an A, you will pass the course. Well, that seems true. You are not getting an A. Okay, well, maybe you're getting a B. Does it follow that you will not pass the class? And the answer to that is no. Just because you're not getting an A doesn't mean you're going to fail. I know sometimes I have overly ambitious students and they feel that way, but it doesn't. Actually, I remember having a student like complain because, or not complain, but nearly burst into tears because they were getting an A minus, and I thought, you really need to get your life in order here. Sorry, I don't know. I guess it's good to be ambitious, but in any event, but this is not a valid way of reasoning here, and hopefully you can see that that's the case, because we can imagine a scenario in which one is true. Well, one, we don't have to imagine, that just is true. We can imagine a scenario in which this is true, and yet the conclusion isn't guaranteed. And we can look at this and figure out the form. If you get an A, you will pass. Well, that form is going to be if P then Q. Got ahead of myself there. Let's go back a second. You are not getting an A, all right? So if we see you are not getting an A, well, that's going to be, let's get my little pen here. Oh, snap. I didn't want that to happen. Get my little pen here. You get an A, then you will pass the course, and we'll let this be P, and we'll let this be Q. You are not getting an A. Well, you get an A is P, you are not getting an A. This is going to be not P, and then you will pass this course. You will not pass the course. So this is going to be not Q, all right? So this form is if P, then Q, not P, therefore not Q. And this is what we call the fallacy of denying the antecedent. Because what are you doing here? The antecedent is P, and you're saying it's not true. And since this is not true, this is also not true. And you can see why this is problematic, because remember, I said a long time ago, it's okay to deny the consequent because the consequent is a requirement of P. But P is not a requirement of Q. P is a sufficient condition for Q. What does that mean? It means P will guarantee Q, but P isn't needed for Q. So, again, like if you, trying to think of an example here of a sufficient condition. If you get shot in the head, then you will die. That doesn't mean, it's not saying that the only way to die is to get shot in the head. It just means that is a guarantee. All things being, I know it could graze you or whatever, but, I don't know. Let's say you get shot in the head by a bazooka exploding. So for those who want to be a little nitpicky. But you get shot in the head, then you will die. That's not saying the only way to die is to get shot in the head. It's just saying this is a guarantee. It's a sufficient condition. So if I said, well, you didn't get shot in the head, or a bazooka didn't blow up in your face, so therefore you didn't die. Well, no. I mean, you could have died because, I don't know, you got electrocuted, or I don't know, someone cast an evil spell on you. I don't know, go back to my earlier, an atomic bomb blew up, or someone cut your head off with a machete. I'm really not a morbid person, by the way. It's just these examples I think are the easiest to follow a lot of times. But there are other ways. Or go back to, I said if you receive the most electoral votes, then you will become president, right? Well, that's a sufficient condition, but that's not the only way to become president, right? Because the person who's president could die, and the vice president, you didn't win the electoral votes. Or the president could resign, like Richard Nixon, and then you could have another way to become president. The president could get impeached and kicked out of office. That's another way you could become president, right? So if you win the electoral votes if you win 270 electoral votes, then you will become president. You win 270 electoral votes. That's merely a sufficient condition. It's not a guarantee. Or I should say, it's not the only path to becoming president. Actually, even saying it like that, it's not a guarantee, because if you win, you could become president. But then let's say, I don't know, and while you're waiting to become president, I don't know, you get arrested for criminal activity, and then you're in jail or something like that. So it's not setting, as I've worded it, it's merely establishing a sufficient condition in order to for the consequent. So this is the fallacy of denying the antecedent. You can deny the consequent. That is okay because the consequent is a requirement. You cannot deny the antecedent because the antecedent is not a requirement. The antecedent is merely a sufficient condition. So if I say, if P then Q, and I say, well, not P didn't occur, that's not ruling out that Q could have, come about through other means, right? P is just giving us one way to achieve Q. It's not giving us all the ways. On the other hand, though, Q has to be the case if P is. So it basically, Q has to be the case if P is. So it's a requirement of P. Anyway, all right. So I just want to lay this out so you can see it. I don't know if this is the most effective chart here, but you can see that we have our hypothetical syllogisms, and at the broadest level we have mixed versus pure. And pure, everything in a pure is, when it says pure, because everything's hypothetical, right? Everything's hypothetical. Mixed, you're going to have at least one premise that is not hypothetical and a conclusion that is not hypothetical. And then under mixed, you have valid forms and invalid forms. And the valid forms are going to be modus ponens and modus tollens. The invalid forms are going to be affirming the consequent and denying the antecedent. And just so you know, this is going to be information you're going to be asked on or tested on your final exam for this class. So do try to learn these, or at least familiarize yourself enough that you can understand them or spot them when you see them. All right. So finally, I want to talk about distilling hypothetical syllogisms. And when it comes to distilling hypothetical syllogisms, you're going to have to, basically, you'll encounter hypothetical syllogisms in natural life or in ordinary life, and you'll see them in natural language and all manner of forms. And we want to be able to put them into, you guess it, standard form. And standard form for the hypothetical syllogisms is just going to be you list your hypothetical proposition first, then you list your non-hypothetical proposition, I should have said non-hypothetical, and then you list your conclusion. Now I say non-hypothetical proposition because if you have a pure hypothetical syllogism, you know, everything in it's going to be hypothetical. But when you're dealing with a mixed hypothetical syllogism, always list your if-then proposition, your hypothetical first. So if you're dealing with a mixed hypothetical syllogism, it should come, you know, if premise 1 should be if-then, premise 2 should be your non-hypothetical, and then the conclusion will also be non-hypothetical as well. If you're dealing with a pure hypothetical syllogism, then you want to list the first hypothetical. So if this is a pure hypothetical syllogism. If you're dealing with one that's pure, the first, everything in it's going to be hypothetical. All your propositions are going to be hypothetical, but you list the one first that has the antecedent that is the antecedent in the conclusion. So in a pure hypothetical syllogism, your conclusion is going to be therefore if, you know, A then B. And what you basically want to do is list the proposition first that has whatever is in the antecedent of the conclusion. That'll be the first one you list. And it should be like fairly clear what the logical sequence of a pure hypothetical is going to be. But again, when you're dealing with a mixed hypothetical syllogism, always basically list the hypothetical proposition first. Now, you know, as far as distilling these goes, I mean, some of these are pretty straightforward. But in ordinary life, you don't always see these arguments presented where the conclusion is listed first, or you know, they're presented in the order I just shared with you. So here's a simple one. If we were going to distill this argument, I don't think John is into Sarah. If he were, he would return her calls, but he never does. So what is the form of this? Well, first thing we got to do is figure out the conclusion, and the conclusion is I don't think John is into Sarah, or just John is not into Sarah. And our hypothetical proposition is if he were, which I'm saying right here, if he were or if he were into Sarah, then he would return her calls. He doesn't return her calls, therefore he isn't into Sarah. So this is the argument right here. What we're saying. If John were into Sarah, he would return her calls. He does not return her calls, therefore he is not into Sarah. A question, and I wish I could talk to you face to face, I would ask you is this a valid argument? And the answer to that is yes. And in fact, this is an example of modus tollens. And hopefully you can see that at this point, because we have John, we're into Sarah. We have our P right here. He would return her calls. Our Q right here. He does not, which is not Q. All right. This is tedious. And then not P. So this is a valid way of reasoning. This is just a straightforward instance of modus tollens. Now, quite often when we deal with hypothetical syllogisms, this is going to be something that is fairly common. People don't always spell out every premise. You'll see this a lot. So this is actually returned to something that a lot of you told me that you didn't really enjoy, which was implicit premises. But you see people just not fill in all the details of an argument they make a lot of times when they make or they produce any kind of mixed hypothetical syllogism. So let's look at an example of what I'm talking about. To take this argument right here, since the universe began to exist, it must have a cause for its existence. Now, what is the argument being made here? Well, the conclusion is clearly the universe must have a cause for its existence, and it seems like the premise of it is the universe began to exist. But how do you move from this premise right here, the universe began to exist, to the conclusion it must have a cause for its existence? It seems like something missing here. And we could, this is when we talked about implicit premises a long time ago. As I said, if a person doesn't tell you what it is they're assuming, there are a lot of different things we could fill in. But at least one way of understanding this argument would be something like this, is if something begins to exist, then it must have a cause for its existence. The universe began to exist, therefore it must have a cause for its existence. And notice here that this up here is a hypothetical argument, but they were, or at least this is one way of understanding it. You actually could understand this as a categorical syllogism too, because you might say all things that begin to exist are things that have a cause for its existence. You know, I said this a long time ago, but universal, affirmative, categorical propositions, there's a huge deal of similarity between those and hypothetical propositions. And so you could actually understand this as a categorical syllogism, but it could also be easily understood, and this is, I think, a natural way for a lot of people to understand this as a mixed hypothetical syllogism. And if we understand it like that, and that's how we're doing it just for the purpose of this particular lecture, you can see here that even though this argument presented up here is only presenting one premise, it's clearly making an assumption right here that I have listed as premise 1. So this is something you do run across a lot of times, where a person will make an argument, but they won't tell you the premises that they're assuming. This is just, I don't know if it's necessarily more prevalent when we're dealing with hypothetical syllogisms, but you just see it occur a lot. Let me give you another example. God doesn't exist. If he did, there wouldn't be so much evil in the world. I've heard this argument a bunch of times. So what's the argument being made here? Well, we'll just start with what they tell us, which is if God existed, then there wouldn't be so much evil in the world. Therefore, God does not exist. This argument, as is presented up here, though, it leaves out something, which is what? That there's a lot of evil in the world. That's what it's assuming. And you can see here we have our hypothetical argument, and this is actually, let's see if we can figure out the form. We'll say God exists, we'll say that's P, then there wouldn't be so much evil in the world. So notice we have our negative here. So it's if P, then, I'm sorry, why did I put P there? Then not Q, because we have to say not because of the negative. And Q refers to there is evil in the world. Then P down here, then the second premise down here, this is just going to be Q, and then the conclusion is going to be not P. And this is actually an instance of modus tollens, because we're saying if P then not Q, Q, right? Or in other words, not Q, therefore not P. This is an instance of modus tollens. But, why I share this with you in this particular instance is because if we look at the initial presentation of the argument up here, God doesn't exist. If he did, there wouldn't be so much evil in the world. If you go by just what's explicitly being said, which is this right here, this is just an invalid argument. It just doesn't work at all, because your premise is hypothetical, but your conclusion is non-hypothetical. You can't just say if P then Q, therefore Q. That just doesn't follow at all. So in order to charitably interpret this argument, we have to kind of help the person out and provide a premise that's going to get us from this pure hypothetical proposition to a non-hypothetical conclusion. And it seems like the most obvious thing, what they're assuming is, as I said, there is evil in the world, or there's a lot of evil in the world, or something like that. That's the assumption, and that's going to get us to where we can establish this conclusion. Now, whenever we're trying to identify any kind of implicit premise in hypothetical syllogism or categorical syllogism or anything, we always try to do it in a way that's going to make the argument valid. Now, we can't always do that, but that's what we want to do. If we can render the argument valid, that's going to be ideal. Because to do otherwise would just be to be extremely uncharitable and to attribute an argument to a person that it just doesn't even seem like the view or the argument they be making or the view they be endorsing. So we always try to render the argument when we can valid. Now, we can't always do that. And sometimes we're like, look, we work with what you're saying, we've done our best, but what you're saying just doesn't work. And that's the way it goes sometimes. So the reason I mention this is because for your homework assignment for next class, you're actually going to have to identify some arguments that have implicit premises. And I want you to do exercises 8.2b. And for these, you're going to have to put each of the following hypothetical syllogisms for problems I have listed right here, put them into standard form. And let's see, you have to identify an implicit premise. Not all of them have one, but if they do, you have to identify them. And then also determine what type of syllogism it is, determine whether it's valid or invalid, And if it's invalid, I want you to tell me the fallacy that it makes. Now, with regard to some of them, I think might be a pure hypothetical, and if you have a pure hypothetical, it might be invalid. And if it is invalid with respect to the pure hypothetical ones, we don't have a fallacy name for those a lot of times. So you can just write invalid for those. But if you're dealing with a mixed hypothetical syllogism, I do want you to tell me the name of the fallacy, like either affirming the consequent or denying the antecedent. So if it's invalid, I do want you to identify that.